Hey guys, let's talk about this final review. Alright, so for number one, you're just going to drop the parentheses or distribute and combine like terms. So we got negative 8x minus 4 plus 2 equals negative 7x minus 35. Alright, so here we go. We got negative 8x, negative 4 plus 2 is going to be minus 2 equals negative 7x minus 35. Alright, I'm going to move the x's to the left, so that's going to be plus 7. It's going to be negative x minus 2 equals negative 35. Negative x equals negative 33. So x equals 33. Alright, there you go. Alright, same thing on number 2. So I'm going to clean this up. So I got negative 7x minus 2 minus 2x minus 1, or sorry, minus 2 equals 7x plus 3. Let's see. It's going to be negative 9x minus 4. All right. Let's see. We got it's going to be negative 16x equals 7. X equals negative 7 over 16. All right. Now on number 3, I can do this, or starting with number 3 rather, I can start to use this method called fraction busting. So in order to add and subtract fractions, you have to get a common denominator. Or you could take what would be your common denominator, multiply it by the whole thing, and that gets rid of your fractions. So 5 and 6 both go into 30. Right, so let's see. 5 goes into 30 6 times. 6 times x is 6x. 6x. 6 goes into 30 5 times. 5 times x is 5x. And then 5 goes into 36 times. 6 times 9 is 54. All right, move the x. X equals 54. Okay. So that's it. Same thing on number 4. 5 and 3 both go into 15. All right, so 5 goes into 15 3 times. 3 times 2 is 6, so it's going to be 6x. 3 goes into 15 5 times. 5 times x is 5x. 4 doesn't have a denominator, so it's just straight multiplication. So this is going to be 4 times 5 is 60. So x equals 60. Right? You can still do the same thing, even though you can still do the same thing on number 5, even though it's x minus 4 is your denominator. Okay, so the first denominator is going to cancel out, so that leaves me with 3. I don't have a denominator on the second one, so it's going to be 1 times x minus 4, so it's just going to be x minus 4 equals 2. All right, so it's going to be x minus 1 equals 2, x equals 3. Okay. Now on 6, I have to have a common denominator, so I need to figure out what all my pieces are. Well, y squared minus 9 factors into y plus 3, y minus 3. So once I know that, then I can do what I've been doing. I can multiply this entire thing by y plus 3, y minus 3. Okay, so on the first one, the y plus 3 is going to cancel, which just leaves me with y minus 3 minus 5 times y plus 3, because the y minus 3 cancels out. And then you have both of them under the 2, so those are going to cancel, and I'm just left with 2. All right, so I got y minus 3 minus 5y minus 15 equals 2. Let's clean it up. Got negative 4y minus 18 equals 2. Negative 4y equals 20. Y equals negative 5. There you go. All right, shifting gears a little bit with number 7. We're just going to factor instead of each factor equals 0. So here, that trinomial factors in 2 binomials. So you got x squared is x and x. The second sign is negative, so it's going to be plus and minus. I get one of each. All right, then I ask myself, what times what is 24? And subtracts to give me 2. Well, that's going to be 6 and 4. And since 2 is positive, it's going to be plus 6 minus 4. All right? And again, I'm setting that equal to 0. So I got x plus 6 equals 0. X minus 4 equals 0. All right, and then you solve each one. You get x is negative 6. X is positive 4. All right. Number 8. I'm going to move everything to the same size. So it's going to be 3x squared minus 23x minus 8 equals 0. All right, there's not a GCF I can take out, so I'm forced to use the AC method, which allows me to get a positive 1 out front. So this can be x squared minus 23x minus 24. And so I asked myself, what times what is 24? And subtracts to give me 23. Well, that should be 24 and 1. And since 23 is negative, it's going to be minus 24 plus 1. Okay, so since part of the AC method is, since I started by multiplying by 3, I have to divide everything by 3 at this point. Some of it will reduce and the denominator will go away. Some of it will simplify, but the denominator will not go away. All right, so I got x plus 1/3. And then this is going to be x minus 8 equals 0. Okay, so any denominator that's left after you simplify, you're going to put it in front of x. All right, so my final answer is going to be 3x plus 1, x minus 8 equals 0. All right, so that's my final factor form. And then you would set each of these equals 0, 3x plus 1 equals 0, x minus 8 equals 0. So x equals 8, 3x equals negative 1, and x equals negative 1/3. And there you go. Number 9, we can kind of get away with something right here. We can use the square root method because 49 is perfect squared, and I need to take a square root to get rid of that. Is an option I can use to get rid of the square on that parentheses. So if I take the square root of both sides, you get x minus 6 equals plus or minus 7. And you have to consider both the positive and the negative versions. And then you just move the 6 over, you get x equals 6 plus or minus 7. All right, so if you got 6 plus 7, that's 13. And 6 minus 7 is negative 1. So those are my answers. Now, some people or some programs get a little bit out of shape if you put them, if you're not in a certain order. I don't care right now. So you just, so they may prefer it that negative 1 came first, but you're just making a list of your answers, and that's fine. All right, so once again, we're going to do the square root method. So I'm going to take the square root of both sides. I got 2x plus 4 equals plus or minus 6, because the square root of 36 is 6. And then move the 4 and divide the 2. So you got 2x equals negative 4 plus or minus 6. And then x equals negative 4 plus or minus 6 over 2. Now, this obviously reduces, but I'm not really concerned about reducing because I don't have any variables, so I can just solve this. So negative 4 plus 6 is positive 2. 2 over 2 is 1. Negative 4 minus 6 is negative 10. And negative 10 over 2 is negative 5. Okay. Now, on number 11, the only way you can factor this is with a quadratic formula. All right, so the leading coefficient of x squared is a, the leading coefficient of x is b, and then the constant term is c. Okay, so here we go. X equals opposite b, so negative 3 plus or minus square root b squared minus 4ac. A is 1, c is 1, all over 2a. A is 1, so it's just going to be 2. And then I simplify. Okay, so you got negative 3 plus or minus 3 squared is 9 minus 4 all over 2 equals negative 3 plus or minus square root of 5 over 2. All right, so that's as far as I can go without getting decimals. This is an exact answer, and so we prefer to leave our answers in exact answers. So this is as far as we go. All right, 12, we're doing the same thing. It's not going to factor whether you use the AC method or whatever. So quadratic formula always works. So it's something that you can put in your back pocket. But here, let's see, I got x equals opposite b, so negative 10 plus or minus square root b squared. So it's going to be 10 squared minus 4ac, 4 times 3 times 4, all over 2a. A is 3, so it's going to be 6. All right, so you got negative 10 plus or minus 10 squared is 100. 4 times 4 is 16. Or 4 times 3 is 12. 12 times 4 is 48. So this is what you got here. Divided by 6 equals negative 10 plus or minus. All right, 100 minus 48 is 52. Okay, so 52 is not a perfect square, but there's a perfect square that lives inside of it. So here's what we got. I can do negative 10 plus or minus, and I can separate the 52 into 4 and 13, because I can take the square root of 4. All right, so that gives me negative 10 plus or minus, the square root of 4 is 2, so I get 2 square root of 13 over 6. So you get negative 10, oops, out front you get negative 10, 2, and 6, all of which can be divided by 2. So this is going to be negative 5 plus or minus square root of 13 over 3. So you simplify your fraction, but you leave it as an exact answer, and there you go. All right, 13. We're trying to find the interval notation for this inequality. All right, so solve it like it was an equal sign. So you get 3x, subtract the 5, you get less than 18. 18 divided by 3 is 6. All right, so I got, draw a number line, I got 6. All right, so it's less than, so I got a parentheses, and I shade to the left. All right, so in interval notation, it's negative infinity to 6, parentheses on both. There you go. 14, it's gonna be 12x plus 2 greater than 10x minus 10. When you're dealing with inequalities, you wanna make sure every x gets to the left and everything else gets to the right. So 12x minus 10x is 2x. All right, so subtract the 2, it's gonna be greater than negative 12. Divide the 2, x is greater than negative 6. All right, so I got my graph. All right, you got negative 6. All right, so it's greater than this time. So this parentheses, shade to the right. So that means I got negative 6 to positive infinity, parentheses on both. Okay. All right, now, with absolute values, you want to make sure the absolute value is by itself first, and then depending on what's by itself, you can look at it and compare it to the inequality, and that can kind of give you some hints of what's going on. All right, so simply get the absolute value by itself on 15, so you got 2x, absolute value of 2x plus 7, less than negative 9 plus 7, it's going to be negative 2. All right, absolute values are distance from 0. Distance can't be negative, so the absolute value is only going to spit out positive answers. Okay, so when is a positive answer less than negative 2? Never. So this is going to be no solution. 16, you got the absolute value of 5x minus 4. Add the 8, you get negative 8. So similar question to 15. All right, it only spits out positive answers. When is a positive answer greater than negative 8? Well, that's always. And so that would be all real numbers. And so you got negative infinity to infinity. All right, so these are 15 and 16 are like special cases when it comes to this. All right, so on 17, you're graphing a parabola. There's several things you can do here. The first thing we're going to do for sure is we're going to do completing the square so that we can get it in vertex form. And then you could also find axis of symmetry. You could find some points. All right, but a parabola is very symmetrical. So we need to know, basically the two things we need to know is the parabola opening up or down, and where's the vertex, which is either the highest or lowest point, depending on whether it's opening up or down. All right, so to complete the square, everything that has an x, I'm going to pair it up together. And so here we go. I'm going to say x squared plus 5x, and I'm going to leave a space, plus 4. Now, to complete the square, I take 5x and I take half of it and square it. So half of 5 is 5 halves, and if I square that, that is, so like 5 halves squared is 25 over 4. So I'm going to add 25 over 4 inside and subtract 25 over 4 outside. All right, so now we just need to clean it up. And by doing the completing the square method, that produces a trinomial that will factor. And it gets this thing to show up. So x plus 5 over 2 all squared. So by completing the square in that first step, it allows this binomial square to show up. Okay, and then 4 is 16 over 4. 16 minus 25 is 9 over 4. Okay, so I got x plus 5 over 2 squared minus 9 over 4. So that's my vertex. Negative 5 over 2, negative 9 over 4. That's my vertex. And the original leading coefficient of x squared was positive 1, so it's going to open up. So let's see, negative 5 halves, negative 9 fourths. It's going to be negative 2 1/2, negative 2 1/4. This is going to be about right there. And we're opening up. Just going to look something like this. Now, if you see something like this on your test, you're going to have answer choices, 4 or 5 of them, and so they shouldn't be that close together. If they are, then you would want to get get specific about your points. So like pick a couple of x's on either side of your point. So if my x of my vertex is negative 2 1/2, maybe I pick negative 2, maybe I pick negative 3, maybe I pick 0, maybe I pick 5. So just pick some integers and find some points, and that can give you a better idea, a more exact graph. But that's the idea here. On 18, we're doing the same thing, but this time I have a negative out front, so that means that parabola is going to open down. All right, so I'm going to group that up, and the first thing I'm going to do is I'm going to pull that negative out, which is going to change my signs. So it's going to be negative x squared plus 2x. Again, I'm going to leave space. Plus 8. Now, half of 2 is 1. 1 squared is 1, so I got plus 1 inside. All right, and then I subtract because it's on the outside. But when I pull it out, there's that negative out front I have to contend with. So I'm subtracting negative 1. Okay, so that's going to be negative x plus 1 all squared. And then you got 8 minus negative 1, so that's 8 plus 1, which is plus 9. Okay, so my vertex is negative 1, 9. And because of the negative out front, I know this vertex or this parabola is going to open down. All right, so I got negative 1, 9, and it's going to open down. So there you go. There's your sketch of a parabola. All right, on 19, switching up, we're going to do systems of equations. You can do elimination, or you can do substitution. It doesn't matter which one you use. I say it usually depends on the problem. So like on 19, it really sets itself up well for substitution. I just need to get y by itself or x by itself. And so I'm going to say x equals 4y plus 16. And what that allows me to do is then I can take x and plug it into the other one. So that's going to be 2x equals 4y plus 16 plus 8y equals 0. All right, so you got 8y plus 32 plus 8y equals 0. So it's going to be 16y equals negative 32. Y equals negative 2. And once you know what y is, you plug it into your x. And so that's going to give you x equals 4 times negative 2 plus 16. All right, so that's going to give you negative 8 plus 16. This is going to give you positive 8. And this, your answer is an ordered pair. So you got 8, negative 2 for your answer. All right, and then for 20, this is really set up for elimination. So I have 6x over 6x, which is great. I just need one of them to be negative. So I'm going to say change the signs of that first one. Okay, so that's going to give me, let's see, negative 6 minus 7x, or sorry, minus 7y equals negative 30. Okay, and so I'm going to get rid of that. That's going to give me negative 5y equals 30. Y equals negative 6. So I'll take that and plug it back into one of my originals. It doesn't matter which one. So let's say I got 6x plus 7 times negative 6 equals 30. And again, it doesn't matter which one of these you plug into. You get the same answer. So you got 6x minus 42 equals 30. 6x equals 72. X equals 12. So you got negative 6. Or sorry, you got 12, negative 6 for your answer. Okay, on 21, 22, it says solve and check. So to get, to solve for x here, I need to square both sides. And so because I'm squaring both sides, I need to check my answers when I'm done to make sure they actually work. Because sometimes this is going to produce more than one answer, and not all of them are going to work. All right, so I'm going to square both of them. The square root's going to fall out. That leaves me with 3x plus 28 equals x squared. So I'll get everything to the same side. So it's going to be 0 equals x squared minus 3x minus 28. Factor that, you get x plus minus, and then 7 times 4 is 28, and subtracts to give you 3. 3 is negative, so it's going to be minus 7 plus 4. All right, so x plus 4 equals 0. X minus 7 equals 0. So x equals negative 4. X equals positive 7. All right, so I said you need to check these. So I'm going to take negative 4 and plug it into both sides, and I'm going to see if one side equals the other. So it's going to give me 3 times negative 4 plus 28 equals negative 4. All right. You should kind of already see this is going to be a problem because you can't take the square of a negative and get a negative. All right, but let's take a look at it. So 3 times negative 4 is negative 12 plus 28. That's going to give you 16. And this is going to give me 4 equals negative 4, which is not a thing. So I can't use that one. All right, and then I check 7. All right, and so 3 times 7 plus 28 equals 7. So I get 21 plus 28. All right, this is going to be 49, which is 7 equals 7, which is just fine. So I get to keep that one. X equals 7 is my answer. I'm going to do the same thing on 22. I'll square both sides, but this time when I square the right side, I get a binomial. So I got to square that, which means I got to write it twice and fill it out. So that's going to be 30x minus 15. If you write it twice and multiply it out, you get x squared plus 14x plus 49. All right, and they get everything to the same side. So you got 0 equals x squared. 14 minus 30 is going to be negative 16x. 49 plus 15, that's going to be 64. All right, and 0 equals x minus 8. X minus 8, which is x minus 8 all squared. Equals 0. So x minus 8 equals 0. X equals 8. Once again, you want to check it out, make sure it works. So you got 30 times 8 minus 15 equals 8 plus 7. So that's going to be 240 minus 15 equals 15. Square root of 225 equals 15. And square root of 225 is 15. So that's all checked out. So I get to keep the 15, or I get to keep my 8. All right. 23 and 24. All right. When dealing with these polynomial or inequalities, you want to make sure everything's in factored form. In 23, you start with everything in factored form. So I got x equals x minus 2 equals 0, so x equals 2. X plus 9 equals 0, so x equals negative 9. All right, so you graph it. You got negative 9 on one side, 2 on the other. And because it's greater than, you're going to shade in opposite directions. So you got parentheses on 2, shade to the right. Parentheses on negative 9, shade to the left. And so my interval notation for this is going to be negative infinity to negative 9. Parentheses, union, parentheses, 2 to infinity. Parentheses on both infinities. All right. On 24, I got to get everything to the same side of factors. So you got x squared plus 5x plus 4 less than or equal to 0. Factor. You get x plus. What times what is 4? It adds to 5, so it's going to be 1 and 4. Less than or equal to 0. So x plus 1 equals 0. X plus 4 equals 0. You get x is negative 1 and x is negative 4. So draw my graph. Got negative 4 on the left, negative 1 on the right. And because it's less than or equal to, first of all, the equal to part is going to make it brackets instead of parentheses. And the and, or the less than, is going to mean I'm going to shade in between. Okay, so my interval notation is going to be negative 4, comma negative 1, bracket on both sides. Okay. All right, 25 and 26, we're now dealing with rational expressions, or rational inequalities. And this is a little bit different. So on first of all, you want to get it in factor form, and it looks like both of these are. So I got x minus 5 equals 0, x plus 3 equals 0. So you set the top and bottom equals 0 to find out any issues you might have. So x equals 5, x equals negative 3. Set both equal to 0 to find your critical points. All right, so I draw my graph, and I get negative 3 on the left, 5 on the right. All right, here's where things are different from before. All right, I'm going to pick a number in each of these sections. So let's say x equals negative 4, x equals 0, x equals 6. All right, and so I'm going to plug in each of these, and I'm going to figure out what my sign is on top and bottom. So if I plug in negative 4 on top and bottom, that's going to give me a negative on top and a negative on the bottom. So a negative over negative is positive. If I plug in 0 for x, I get a negative on top and a positive on the bottom, and one of each is going to be negative. 6 is going to give me a positive on top and bottom, which is positive. All right, this entire thing says, when is that fraction less than 0? Less than 0 means negative. Okay, so what I'm going to do here is 5 is perfectly fine. I can have, or scratch that. Because it says less than 0, it's parentheses, negative 3 and 5, and shade in between. Because that's the only section that's negative, which means it's, and negatives are less than 0. So that's that. And then my answer is negative 3, 5, parentheses on both. 26 is very similar. You got negative x plus 5 equals 0, x minus 4 equals 0, so x equals 4. Negative x equals negative 5, x equals 5, so you got your graph. You got 4, you got 5. All right, so I'm going to pick some points. Let's do x equals 0, x equals 4.5, x equals 6. Okay, so if I plug in 0, that's going to be a positive on top and a negative on the bottom, which is going to be negative. If I plug in 4.5, it's a positive on top and a positive on the bottom, so plus over plus, so that's plus. And then if I plug in 6, that's a negative on top and a positive on the bottom, so that's negative. So I want to know when is this greater than or equal to 0, so I'm going to shade where the answers are positive. Okay, and because it's greater than or equal to 0, I can include some of my solutions. So if it makes the fraction 0, it's fine, but if it makes the fraction undefined, I don't include it in my answer. So the numerator, the 0 for the numerator is 5. All right, so I can include that one, but 4 is my 0 for the denominator, and I can't divide by 0. So I'm just going to use the parentheses on that one, and then I'm going to shade in between. So for rational expressions or rational inequalities, you find your critical points, and you test each section and see which one provides you with a true statement. Okay, on 27 and 28, we are dealing with getting common denominators and adding and subtracting rational expressions. All right, so for on 27, I need to get everything in factor form first. So x minus 1 and 2. This is going to be x plus 1, x minus 2. Or sorry, x plus 1, x minus 1. Okay, so each one of these has an x minus 1. So I need to multiply each fraction by what it doesn't have. So on the right, I'm going to multiply by x minus 2 over x minus 2. And on the left, I'm going to say x plus 1 over x plus 1. All right, so on top, I got 4 times x plus 1 plus 7 times x minus 2 over all three of these, x plus 1, x minus 1, x minus 2. All right, and so this is going to be 4x plus 4 plus 7x minus 14 over that denominator. All right, so it's going to be 11x minus 10 over that denominator, and that's your answer. All right, 28. So I got x plus 1, x minus 1, and then this factors into x plus 1, x minus 1. Okay, so the last fraction has everything it needs. So the first fraction needs an x minus 1 over x minus 1. This needs an x plus 1 over x plus 1. Okay, so I got 5x times x minus 1 plus 6x, or 6 times x plus 1, minus 10. it's going to give me x plus 1, x minus 1. All right, so that's going to give me 5x squared minus 5x plus 6x plus 6 minus 10, x plus 1, x minus 1. All right, so this is going to give me 5x squared let's see, this is going to be minus or plus x minus 4 over x plus 1, x minus 1. All right, so I need to do the AC method here to factor. All right, so by doing that, that's going to give me x squared plus x minus 4. Or sorry, not, that's going to be x squared plus x minus 20. All right, so that's going to be factor x plus minus. It's going to be 4 and 5. And since the middle term is positive, it's going to be plus 5 minus 4. I'm going to divide everything by 5 because I'm multiplying by 5 and have to undo it. All right, so it's going to be x plus 1. It's going to be 5x minus 4. All right, 5x minus 4 over, x plus 1. All right, so I can cancel the x plus 1s. 5x minus 4 over x minus 1. All right. All right, on 29, I'm going to multiply. It's going to be 5 times 3 is 15. And then when you multiply like bases, you add your exponents, so you get 3/4 plus 1/2. All right, using your calculator, you can find out that 1/2 is 2/4. Okay, so that's going to be 15x to the 5/4. All right, there you go. On 30, we have 14 divided by 7 is 2. And then, like on 29, when we were multiplying like bases, we added exponents. On 30, we're dividing like bases, so we're going to subtract exponents. It's going to be 2/3 minus 1/4. All right, so it's going to be 2x 8 over 12 minus 3 over 12 equals 2x 5 over 12. All right, and then let's see. So I'm going to distribute that 1/2, so that's going to be 36. So 1/2 x to the third y squared. Well, 36 to the 1/2 is the square root of 36, which is just 6. So you get 6x cubed y squared. All right, on 32, we're finding the slope-intercept form of this line. First thing we need to do is find the slope. So we got 4 minus 6, 4 minus 5. So this is going to be -2 over -1, which is +2. All right, so you have your point slope formula. So that's going to be y minus, so y minus y1 equals m times x minus x1 is your point slope formula. All right, so I got 4 minus, it doesn't matter which point you pick. Let's do 4 equals 2 times x minus 4. Y equals, y minus 4 equals 2x minus 8. Y equals 2x. Add 4, you get minus 4. So y equals 2x minus 4 is your answer. All right, same thing on 33 and 34. So on 33, we have slope is 4 minus 5 on top, 6 minus -1 on the bottom. It's going to give me -1 on top and 7 on the bottom. Okay, so let's say I got y minus 4 equals -1/7 x minus 6. All right, that's going to be plus 6 over 7. Okay, so we know that 4 equals 28 over 7. So I'll plug that in. So y equals negative 1 over 7, x plus 6 over 7 minus, or rather plus 28 over 7. All right, so y equals negative 1 over 7x, and 6 plus 28 is 34, so plus 34 over 7. All right, one more of these. All right, so I got slope is negative 5 minus 7, or negative 5 minus negative 7. And then I got negative 7 minus negative 6. All right, so this is going to be 2 on top and negative 1 on the bottom, so it's going to be negative 2. All right, so I got y minus negative 5 equals negative 2 times x minus negative 7. This is going to be y plus 5 equals negative 2x plus 7. Y plus 5 equals negative 2x minus 14. Y equals negative 2x minus 19. All right. Now, if we want to graph a line, so when it's in this form, this is called standard form or general form. And you could do one of two things. You could go ahead and solve it for y equals, or you can use the fact that when you're dealing with the x-intercept, y is 0, and when you're dealing with y-intercept, x is 0. So you could do either one of those. So if we just solve for y, let's do this. We got negative 5 equals negative 3x minus 4. Y equals positive 3/5, x positive 4/5. Okay, so the 4/5 is my starting point. So it's going to be right here. And then up 3, right 5. So it's going to be 1, 2, 3, 1, 2, 3, 4, 5. So be right there. And so I connect my dots. That's my line. All right. Okay, on 36, 37, 38, and 39, we're trying to find domain. Your domain wants to be all real numbers, and the only thing that keeps it from being that is if you are dividing by 0 or if you have a negative under the radical. So on 36, our denominator's in factor form, so I don't have to do anything there. I just need to set each one of these equals 0. So x plus 9 equals 0, x minus 3 equals 0. Solve each of these, you get x equals negative 9, x equals 3. All right, so if I plug in negative 9 or if I plug in 3, it breaks my fraction, so I'm actually going to throw those out. So my domain for 36 is x does not equal negative 9 or 3. Because if I let it equal either one of those, it breaks my fraction. On 37, this is going to factor into x plus 1, x minus 1. So you got x plus 1 equals 0, x minus 1 equals 0, x equals negative 1 or 1. Okay, so same thing. Once you know what's going to make it 0, you throw it out. So x does not equal plus or minus 1. Okay. Now, it can be 0 under the radical, but it can't be negative. So this is going to be 20 minus x is greater than or equal to 0. So that's going to give me negative x greater than or equal to negative 20. X is less than or equal to 20. Because when you multiply or divide by negative, you got to flip that inequality. All right. So that is my domain. So when we were dealing with the fractions, we figured out what made it 0 and threw it out. Here, that is my domain. And so you got 20 bracket and negative infinity on the left. And there you go. It says x is less than 20, so 20 has to be your high end. And we write these things from least to greatest. So negative infinity to 20, 20 gets a bracket, parentheses gets a parentheses on the infinity. Now 39, it's very similar to what we just did, but we don't include the equals this time, because if we let it equal, so this would be x minus 2 greater than 0, because I can't equal 0 in the bottom of a fraction. So it's a subtle difference, but it's an important difference. So this is going to be x is greater than 2. So you got 2 to infinity, parentheses on both. All right. Okay, so on 40, we're going to take, we got a function of f, we got a function of g, and we're going to take 4, plug it into g, and get that answer, and take it and plug it into f. So I got g of 4. This is going to be 9. That's not 9. This is going to be 19 times 4 minus 2. And that's going to give me 74. And then I'm going to take the 74, I plug it into f. So I got f of 74 equals 9 times 74 squared minus 7 times 74 equals, and that's going to be 48,766. Okay. On 41, we're doing the same thing, but now it's just generic. So I got f of g of x by saying f4 times, and it's where x is, I'm going to plug in g, so it's 2x minus 1 plus 8. And now I simplify, I get 8x minus 4 plus 8. So that's going to be 8x plus 4. All right, we're going to finish this thing up talking about exponents and logs. So on number 42 here, I'm going to take this, to solve this, let's say 3 raised to the 4th power equals x. Okay, and so 3 to the 4th is 81, so you get x is 81. It's pretty straightforward. On 43, similarly, I got 6 cubed equals x minus 2. Well, 6 cubed is 216. All right, and then add the 2, and you get x is 218. All right, now for 44 and 45, the x is in the exponents, and so to get it down, I need to take the natural log of both sides. So I have the natural log of e to the 4x equals the natural log of 8. The natural log of e goes to 1, so 4x comes down equals ln 8. And so x equals ln 8 divided by 4. This is your exact answer. They could ask for a decimal, and if they do, that decimal is going to be 0.52. All right, for 45, I'm going to take the natural log of both sides like before. X plus 6 equals natural log of 4. All right, ln e goes to 1. My power comes down, so I get x plus 6 equals ln 4. Subtract the 6, you get x equals negative 6 plus ln 4. That's your exact answer, but if you want a decimal, then it's going to give you a negative 4.61. All right? That is your final review. Hope you got something out of it, and good luck on your final.